Okay, now we've got the setup basically done. We've got our pipe supported by the lab stand on one side, rubber band, and the channel itself, the optical rail itself. We've got our photo gate looking through that hole, that half-inch hole in the, oops, see I just triggered it, through that half-inch hole in the Schedule 200 pipe. We've got our pin blocking the pipe. We now have our ball in the pipe. And if we were just playing around, we would be ready to go. But we're not just playing around, we're trying to do science here, so we need to take some measurements. Measurement number one is going to be the inclination of the pipe. And the way you measure inclination is with this thing. Looks kind of like a clock. It's technically called an angle finder, otherwise known as a clinometer. And I need to adjust the focus on this, so there's going to be a quick cut. Okay, so now you can see a more detailed view of the angle finder. First thing to look at is not the dial itself, but rather the base. This model happens to have a flat magnetic base on one side and this angled channel on the other side. See, there's the angled channel right there above my thumb. Now, if we're going to measure a round surface like this here pipe, we actually need to use the angled channel. But this presents a minor problem in that if the magnetic base is level, it gives us a measurement of 0 degrees. That will eventually come to 0 degrees. But if the channel is level, it'll give us a measurement of 90 degrees. So all we have to do, and you notice that, by the way, the angle of inclination decreases on either side of 90, so that's 80 degrees there, 80 degrees there, 70 degrees there, 70 degrees there. So basically all we have to do is take our measurement using the channel, subtract that measurement from 90 degrees, and the absolute value of that will be the inclination of the channel. So let's go ahead and do that. This is a little tricky because you need to balance, the angle finder directly on the channel, on directly on the pipe. If you keep holding it, the minor vibrations in your hand will make sure that that needle never comes to rest. So very carefully let go of it and then just wait. Try not to lean on the table while you're at this, because that will upset the measurements as well. Okay, so the needle has now come to rest at 81 degrees. Actually, I'd call that 80.5 degrees. It's a little bit shy of 81. So 80.5 minus 90 gives us negative 9.5. Absolute value of that is 9.5. So right now, our pipe is at a 9.5 degree angle. That will be one of several measurements you need to make. There's going to be another cut while we get to the other measurements. Okay, so we just took our inclination measurement. We got 9.5 degrees out of that. Now it's time for some linear measurements. And in order to do that, we need a tape measure lying directly on top of the pipe and the optics bench. Now this tape measure is it's the kind of tape measure that physics teachers like because it's marked off in metric. The first measurement we need to do, like I said, the first linear measurement, and the second measurement overall that we need to do is the length of the pipe. And specifically we want the length that the marble travels down, or the ball travels down, after we release the pin. So we have to start with the 0 line at the location of the pin. Now remember, the end of this tape measure is not 0. The 0 point is about 5 millimeters inside the edge of the tape measure. That allows the tape measure to be dented, cut, banged around a bit for about 5 millimeters before it starts affecting the accuracy of the measurements. Alright, so we got 0 at one point. Let's go over to the other side here. There we go. Now again, just like with the bubble level, we want to make sure that something that's a circle, if we view it edge on, it'll look like a line. So the edge of the Schedule 200 pipe looks like that. It's a circle, but we want to take our measurement from that point of view right there. And to me, that looks like 46.00 centimeters of slope. Okay, remember, you can estimate to 1/10 of the smallest increment on any measuring device. This measuring device is marked off in tenths of centimeters, so 1/10 of the smallest increment would be 1/100th of a centimeter. So we can call this 46.00 centimeters. Okay, now let's measure the level part. Okay, first get this thing aligned a bit here. This is the problem when you are both the cameraman and the primary actor of your video. I wouldn't call this acting, but anyway, slide that underneath the pipe just a little bit. There we go, that's perfect right there. So the 0 is right underneath the edge of the pipe. Then you're going to need the marble. So go ahead and pull the pin out way over here. But be ready to catch the marble because it goes down surprisingly quick. There we go. Alright, now the reason we needed the marble, by the way, check your alignment right there. Okay, the reason we needed the marble is because on this end, we need to figure out the position where the marble, the first position, where the marble triggers the photo gate. Let's stop the photo gate just because I find that mildly annoying. Okay, so watch the LED, this thing. Watch the LED as we roll this along. There we go, right there. It lights up right there. When the front edge is at the marking, let me get that in real nice focus. There. .82, so that's the 80 mark there. 82.1 centimeters. 82.10 centimeters. Might be a little hard to see. Maybe, no, that perspective won't help either. Okay. Hang on, I'm just going to, yeah, leave it right there. There. Yeah, 82.10 centimeters. Alright, so 82.10 centimeters of level track, 64.00 centimeters of slope. Now we're actually ready to take our final measurement, which is the time required for both the travel down the slope and across the level track. Okay, so now that we've taken the measurements we need to take, by the way, be sure to take the tape measure out of the channel, out of the optics bench. Now that we've taken the measurements that we need to take, we're actually ready to do some experiments. Before, there's a couple steps that you need to do at the beginning of every run. First thing you need to do is grab the pin and the marble. There we go. Pin in the marble. Put the pin through the pinhole. to make sure it goes through both sides of the pipe. Might take a little bit of change of perspective in order to do that. There we go. Put the marble in. Check to make sure the LED is not being triggered on this side. You might want to do a quick test run though to make sure that when you move your finger in roughly where the hole is, it does in fact trigger. Then you need to go down to the other side. As you can see, I've discovered manual focus. And make sure that the photo gate timer is stopped and reset. If you don't do that, you will get a completely incorrect measurement. Alright, so now we are ready to go. It will help if you have your lab partner on this end of the bench ready to catch the ball as soon as it passes through the photo gate timer. After the ball passes through the photo gate timer, you don't care about what else happens to it. Alright, so no need to coordinate, you just yank out the pin. There we go. And, alright, that was problematic. See what happened there is that the ball came through, bounced off, and then went back through the photo gate timer. I didn't plan this, but it's actually a good lesson because we just want the photo gate timer to stop as soon as it hits this, as soon as the marble passes through this beam. So one way to do that is to take this silver switch in the middle, and that's the memory switch, set it to on, and then reset this. And what will happen when you have the memory on is that it'll start the timer after the first interruption, it'll stop it after the second one, and then no matter how many times you interrupt it after that, it's not going to change what's displayed on the clock. You can still reset it as normal. And so one last thing to do is to make sure the memory is on. Okay, so moving back over to here, we reset. Come on, focus, baby. Alright, there we go. Alright, so this goes in the top here. And that goes through there. Load that in. Okay. Check. Check. The reset button. And now we're ready to take a bona fide measurement. Okay, so now we have a measurement of 1.768 seconds. Now you just got to do that a bunch more times. Follow the instructions on your lab handout to distinguish how many times you need to do this and at what range of angles are acceptable. Generally speaking, keep your pipe angled at less than 10 degrees and you'll be fine.